Hi, this is Jant. In previous class, we have solved some important problems of complex number. Today, let us know how to find the nth root of a complex number. We know that a complex number can be written in polar form as z equal to r e to the power I theta, where r and theta are the polar coordinates. So the nth root can be written as z to the power 1 by n equal to r e to the power I theta to the power 1 by n. So this nth root can be designated as omega. If you want to find the nth power of the complex number, then we can write z to the power n equal to r e to the power I theta to the power n. Now let us solve a question. Find z to the power 4, z to the power 1 by 3, where z equal to 3 plus 4i. Here we have to find the nth power of the complex number, and here we have to find the nth root of the complex number. So this is the difference. Here we have given in this question z equal to 3 plus 4i. So now see, this complex number is in the form of Cartesian coordinate, where x equal to 3, y equal to 4. First of all, we have to convert these Cartesian coordinates into polar coordinates. So according to formula, we can write r equal to square root x square plus y square. So the value will be 5, and theta equal to tan inverse y upon x. So this will be tan inverse 4 upon 3. Now if we want to write this complex number in polar form, then we can write z equal to r into e to the power I theta. So here we can put the value of r and theta. So this will be 5 e to the power I tan inverse 4 upon 3. This is the value of complex number in polar coordinate system. So first of all, here we have to find the value of z to the power 4. So now we have to put the value of z here. So we will have 5 e to the power I tan inverse 4 upon 3 to the power 4. So we can write this as 5 to the power 4 e to the power I 4 tan inverse 4 upon 3. So this is the result for z to the power 4. Now let us find the value of z to the power 1 by 3, or we can say the third root of the complex number z. So we can find in this way. We know that a complex number can be written in polar form as z equal to r e to the power I theta. So now we can write this z equal to r e to the power I theta into e to the power I 2 pi k. Since e to the power I 2 pi k equal to 1, so this is equal to r e to the power I theta plus 2 pi k. This is the value of z. Now if you want to find the nth root, then we can write the roots as z to the power 1 by n equal to r into e to the power I theta plus 2 pi k to the power 1 by n, and this quantity is represented as omega. Omega designates the nth root of a complex number. So we can write omega equal to z to the power 1 by n equal to r to the power 1 by n into e to the power I now see here, where k equal to 0 1 2 up to n minus 1. Now if we want to find the third roots of the complex number, third root of complex number z, then we can write this formula as omega equal to z to the power 1 by 3 equal to r to the power 1 by 3 e to the power I theta plus 2 pi k divided by 3, where k equal to 0 1 2. See here, the value of n is 3, so the last value will be 2. So we can write k equal to 0 1 and 2 here. So the roots can be written as, this is the first root, and the first root can be found by using k equal to 0. So the first root is given by omega 0 equal to r to the power 1 by 3 into e to the power I theta upon 3. Now the second root can be found by using the value of k equal to 1. So omega 1 is given by r to the power 1 by 3 e to the power I theta plus 2 pi upon 3, and the third root can be found by using k equal to 2. So the third root is r to the power 1 by 3 e to the power I theta plus 4 pi divided by 3. So omega 0, omega 1 and omega 2 represents the three roots of z. Now let us solve another problem, that is find the square root of 1. We can solve this type of problem in the following way. We know that 1 can be written as e to the power I into 2 pi, and also we can write 1 equal to e to the power I into 2 pi k, where k equal to 0, 1, 2 up to n minus 1. Now multiplying equation 1 with equation 2, the left hand side will be 1 into 1 and the right hand side will be e to the power I 2 pi into e to the power I 2 pi k. So this is equal to 1 e to the power, take common I 2 pi and we will have 1 plus k. So now if you want to find the nth root of 1, then we can write this expression where k equal to 0, 1, 2 up to n minus 1. So this represents the nth root of 1. Now if we want to find the square root of 1, we can write square root of 1. Then we can write 1 to the power half equal to e to the power I 2 pi whole into 1 plus k divided by 2. So this represents the square root of 1, where k equal to 0 and 1. So the roots can be written as, first one is omega 0 and this is for k equal to 0. So we can write e to the power 2 pi I upon 2, this is equal to e to the power pi I, and that value can be written as cos pi plus I sin pi. Cos pi is minus 1, sin pi is 0, so this value is minus 1, and we can get the second root by using k equal to 1. So it can be written as e to the power I 2 pi 1 plus 1 upon 2. So this will be e to the power 2 pi I, and if you will solve, then we will have the value is 1. So this is the first root, this is the second root. First root is minus 1, second root is plus 1. Similarly, we can find the third root of 1, and that is the homework for you. Find the third roots of 1. See here an interesting question. First write down this question. If a complex number z is multiplied with 1 minus I, then by what angle the radius of z is rotated. So we have a complex number z and we have to multiply another complex number 1 minus I, and we have to find by what angle the radius of z is rotated. So initially the complex number was like this, and this makes an angle theta with the real axis, and if you will multiply 1 minus I with this complex number, then we have to find the angle rotated by z. So now see here, we can write this z in polar coordinate form, that is r e to the power I theta, and this complex number is in the form of Cartesian coordinate. Now we can convert this into polar coordinates. Here x equal to 1 and y equal to -1. So these are the Cartesian coordinates, and we can convert into polar coordinates by using the formula r equal to square root x square plus y square, that is equal to root 2, and theta equal to tan inverse -1, that is equal to 135 degree. So we can write 1 minus I in polar form, that is r e to the power I theta, this is root 2 e to the power I into 135 degree. So now let's put this value here. We will have root 2 e to the power I into 135 degree. So this is equal to root 2 r e to the power I theta plus 135 degree. So now see here, when the complex number z was here, the amplitude of z was theta. Now when complex number z is multiplied with 1 minus I, the amplitude increases 135 degree. So here we can get the complex number z whole into 1 minus I rotated an angle 135 degree anti-clockwise. See here, anti-clockwise. So we can draw the complex number z whole into 1 minus I, and this angle is 135 degree, and the total angle of z whole into 1 minus I with real axis is theta plus 135 degree. So we will continue from the next class. Thank you.